Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwari John. In our last class, we discussed some special number sets. We talked about the natural numbers n. We talked about the natural numbers. We also talked about the set of integers. And we also talked about the set of rational numbers. And one thing you must remember about the rational numbers, all decimals, I mean terminating decimal and repeating decimals are part of the rational numbers. All decimals, I mean terminating decimals and repeating decimals with patterns, are members of the rational numbers. But in today's class, we'll be looking at different sets of special number sets, and the first we want to look at is the irrational numbers. Now the irrational numbers is denoted by I, okay, and they are numbers that cannot be expressed in this form. They can't be expressed in this form, P over Q. So they cannot be expressed like this. It implies that they are not fractions, they are not terminating decimals, they are not repeating decimals. So they are decimals without patterns, and they go on till infinity. So they don't terminate and they don't have patterns. Such kind of numbers include numbers like √3 or √2, √3. We also have numbers like pi, etc. So these numbers, they don't terminate, they don't repeat patterns, okay? So they are called irrational numbers. They cannot be expressed in this form. All right? Now someone may say, but pi is 22/7. Someone may say pi is 22/7. This is just an approximate value for pi. This is not pi, but an approximate value for pi. Okay? Good. Then the next set of numbers I also want to talk about are the real numbers, denoted by this symbol here, R. So the real number is a bigger set. It contains the set of integers, it contains the set of rational numbers, and it also contains the set of irrational numbers. So the irrational numbers, the rational numbers, and the set of integers make up the set of real numbers. Examples of real numbers: you have -2, you have 5, you have 3/9, you have 2.994, and so on. You can also have pi there, etc. Okay, so these are examples of real numbers. Now the last set of numbers I want to talk about is the set of complex number. These are numbers of the form a plus bi. So where a is the real part, so this part is the real number part, while this other part is the imaginary, b is the imaginary part, and I is called the imaginary unit. We have examples of such kind of numbers. Let's say 2 plus 3i. So this, when you see this kind of number, is called a complex number. Okay, the complex number is a bigger set than the real number, because the real number is a member of the complex number. If you see here, the complex number has a real part and an imaginary part. Okay, so to conclude today's video, or class, I want to say, from our previous class, we say that the natural numbers are subsets of the sets of integers, and the sets of integers are also subsets of the sets of rational numbers, and the set of rational numbers are also subsets of the sets of real numbers. And the sets of real numbers are subsets of the sets of complex numbers. Okay. So mind you, the irrational numbers are subsets of the real numbers as well. Alright? So that will be all for today's video. Please don't forget to like, to share, and to comment. Thanks for watching. Bye.